This is Lego programming for 8-bit computers. I was up at 3:30 a.m. the other night making VCF East versions of my slides, and I have no idea what USB stick are on apparently. Luckily, I have this older version, which I'll improvise with from Kansas Test, which is an Apple II event every year. So I can improvise. I'm going to show the IBM side too. I'll have to improvise, and I apologize for that. So, you all know about Lego Mindstorms, right? Okay. Have any of you ever used this 80s kit? Good.
What?
Have you ever used the 80s version?
Yes.
Okay, pretty exception. So, I will quickly explain how I got from birth to here. I was like the ultimate Lego kid when I was a child in the 70s and 80s. Learned logo electrographics in 5th grade. Microsoft Basic in middle school. The only redeeming quality of religion in my life as a child was getting out here from our bar mitzvah. Thank you so much, thank you. I swear this is a true story. I remember like it was yesterday. I was 12 years old, maybe 13 years old, whatever. I remember like it was yesterday telling my parents I wish there was a way to connect my Apple II to my Legos. Turns out there was. It came out that year, 87. I didn't know about it. And it's interesting because my family had a Commodore budget. Well, we had an Apple II, and my mother worked for the Board of Education, a teacher's discount. And this kit was only available to schools. So if anyone should have known about it, it should have been me. But I didn't find out about it until a long time later. That would have made my childhood if I had this kit back then. But after middle school, I got out of computers, had different interests. Now this is catching up to VCF, and I still shun other people to play there. Something never changed. Okay. Do you all know what the Hope Conference is? Do any of you know what the Hope Conference is? Okay. Hope is Hackers on Planet Earth, basically the East Coast DEF CON, every even number year in New York City, put on by our good friends at 2600 Magazine. So, the last one will be this summer. On the last one, myself and Jeff Grace, one of our other leaders, we're trying to come up with an interesting hacker-like demo for the show. And we said, let's do vintage computer robotics. So one guy, Bill Subrink, had a robot arm for IMSI, and you're a robot guy, etc. And one of our members, Ben Greenfield, said, why not this Apple Lego kit? I said, you have what? It's like, yeah, Apple II for me. I'm like, you're kidding. Like, were you in my dreams 30 years ago? Is that real? And he gave it to us. He gave it to us new in box, never opened. He ordered it from Lego in the 80s, never opened it. Like the postal mail, never opened. I said, how long will we have this for? Like, how long have it been? It's like, well, I sit on my shelf 30 years, so. So I had the honor, I was unboxing it. It was amazing. I don't have any pictures of that. I stink. Anyway, that summer I had bone tumor surgery in my leg. I got a really bad scar here. I tell people if my cat got me, or you should see the other dude. So a brush of cancer will need something to cheer you up. Couldn't work for a month. I was physical therapy for 3 months. I'm a runner. I've been doing for a year. So this was the best medicine. I got to sit around and play with this all summer. It's great. If you pick 100 people at random at this event, I'm probably like 98th in technical altitude. But I don't know much. Some of this may seem overly simplistic, even kind of pointing to you guys, the actual programming, how simple it is. But I learned a lot doing it because I left off in 7th grade, basically. So I got to learn a lot as if I had taken an 8th grade class. So I hope you appreciate it. So, first there was a Lego model in 85 or 86 called Robot Command Center, which wasn't a robot. It's just a static Lego model. It looks like a robot. So don't be fooled by that. Then there was this kit, and then a few years later, there was like a DOS and Windows version, even a Windows 95 version, and then there was the Mindstorms in like 97. And it's funny because everyone today was Mindstorms. I take this demo when I prepare there for Maker Faire and those kind of events, and all the people, especially teenagers, say, well, where do you hide the microcontroller in there? What do you do, Arduino? How do you do that? No, that's my microcontroller. So there's no modern technology. I went out of my way. I'm not doing anything that wasn't perfectly doable in 1987. No modern tricks. You had your choice. Lego supported the IBM PC or the Apple II. it's difficult to bring an IBM PC on a subway to things like Mayfair in New York. I drive a Mazda Miata, doesn't fit too well. Same with the full-size Apple II. So I said I'll use a 2C, a little mini version. What's the problem with that, though? 2C doesn't have a card slot. You need a card for this, because Lego gives you an IBM card and an Apple II card. So I use a Laser 128, which is a 2C plus knockoff with a card slot. And then for the IBM side, now I'm improvising with up now, I use a Compact Portable 3. So I have, in the museum, starting this summer, I'll have my formal demo with an IBM and an Apple, and no IBM or Apple this summer. That'll love clones. Jonathan Chapman, also known as System Glitch, who's in that room right now, doing his 8085 single board computer demo. For some reason that I don't understand, the kit that was new in box sealed from Lego had the IBM card in it, but the box for the Apple II card was empty. It was missing the Apple II card. If he had opened it 30 years ago, he would have sent it back saying we have an Apple II card. So we were stuck.
You should have returned it.
Right? But we found the schematics online. And John makes his Apple II prototype. We're only 3 chips. He goes, I'll make you one. So I have that card. I have the prototype, actually. These are pictures of the cards. I'm going to skip over the electronics and how it actually works, because frankly, I don't understand it. Someone else made the slide. There's a card cage. The way these single expansion slot lasers are supposed to work is you plug in a cage and give you 2 slots. That Laser 128 card cage is unobtainium. But Ian Primus, one of our members, said, Evan, the cage itself is just an Apple II card slot. You can plug a card directly into there and just have one. It's fine. I said, okay, what do I do for the cage to make sure no one pokes at it? And this guy, Michael Mulhern, on the Apple II Facebook group, he's in Australia, and he said, half kidding, half serious, make it out of Lego. I'm like, yeah, okay. So I made the card cage out of Lego. And I shaped it, slowed like a computer, put a slot in the back or a ribbon cable. Turned out pretty well. And I put this little fake antenna dish on top. And we were at Maker Fair, and a young man about your age asked me how it works. I said, well, the data comes out of the satellite dish, bounces off the ceiling, goes to a robot. And he said, oh yeah? Where's the dish on a robot in, huh? And I was like, you little brat. And he was like, and I realized he was mini-me 30 years ago. I was totally that kid. Some things never change. Like it's a joke. Okay. A little Velcro dots to hold it on there. But. Okay, this is the IBM card, which is much more complicated as you see.
It has a typo. And it has a typo.
Yes, address switch. And, okay, it's fortuitous you said that. That's not the only typo Lego made. A much more important one that's functional. I'll get to that. Which are on my other slides that you can't find on the improvise here. Good catch. This is this plastic box here. This is a Lego part. Again, always on the schools. So, from right to left, you have the big red power button. The thing above that is the always-on test port. Then you have ports 0 to 7. Ports 0 to 5 are used for motors. Motors are lights, little LED lights that Lego sold. And ports 6 and 7 are for sensors. They supply an opto sensor and a touch sensor. That is the inside of the thing, the box. This is the only part for which the schematics are not online, and I already have a couple of our volunteers who can do the schematics for me. On my personal time, separate from my involvement with VCF, I'm making a new website because none of this is documented on Lego.com. And there's a couple of blogs here and there about it, but there's no one good website that really documents it. There's a good website from a guy in Australia that documents the what and how it works. It doesn't really document how to use it, how to program it. So I'm making a website for that, and I bought a domain called LegoRobotMuseum.com. Got a cease and desist letter from some law firm in Lego. You can't use the word Lego in your domain. You can own it, you can't use it. And one of my friends said, just tell them it's actually the Legoro Bot Museum. It doesn't work that way. So I bought a new domain, which I called Minds Before the Storm, which is a play on Mindstorm, Minds Before the Storm. And I just forwarded LegoRobotMuseum.com to that one. Lego law firm offered me what I paid for the domain, which is like $12. I'm like, so they're paying $100 an hour to offer me $12 for it. I'm like, if it's so important to them, let them pay what it's worth. So I'm keeping that as spite. I don't need the 12 bucks to keep it in a display. If any of your engineers, you know these parts are, I don't. I was an engineer. We'll just skip this stuff. That's boring. That's boring too. Okay. So, I guess, so Lego provided either BASIC for the IBM PC or Logo for the Apple II. So there were 5 experiments. Experiment number 1, BASIC for the IBM. It did not work. We brought it to Hope Conference in 2016, and I'm a much better programmer now, 2 years later than I was then. But my programming was spaghetti code, but it wasn't broken. It was ugly, inelegant, but it was totally functional. But the robot just wasn't responding. The motors would get stuck on, would turn off, wrong timing, etc. And Jonathan Glitch over there, made the card, said in his opinion there was a timing issue. I was using at the time a Network General Sniffer, which is a Compact 386, which runs at 4 megahertz, whatever, something like that. IBM PC runs at 1.7 megahertz. And Jonathan said it was a timing issue. So we kind of gave up on that. But it worked out okay because I hoped they were more impressed to see what I was building than to see something finished. So the demo went fine anyway. But it didn't really work at all. Which we thought was because I had the wrong kind of IBM compatible. So experiment number 1 kind of failed. This is the basic code for the IBM side. The first subroutine, 9950 to 130, initializes the chips on the card. The other routines are just how to turn on bits, turn off bits, etc. We'll get back to this later because there's a critical type of it. Okay. Experiment number 2, Apple II and Logo. Call that pass-fail. It works. The logo code, you can program a logo, make your robot do interesting things, it works fine. But it turns, last summer, 2016, I was 42 years old at the time. It turns out the imagination of a 42-year-old quickly exceeds the imagination of a 12-year-old, which is a mentor. I was trying to get it to do things that Logo just can't do. And the problem was the computer, the software, couldn't do what I wanted. It just wasn't capable. So I'll call that one pass-fail. This is the boot screen for Lego Logo. First thing you notice is the Legos are upside down. Why? I have no theory on this. Someone joked I put the disc in backward. Disc in upside down. It drives me nuts. I stayed up nights for a week trying to figure out why. Why did it make the Lego upside down? What possible reason? Even if it was a mistake, a dyslexic programmer, when someone at Lego noticed, it's bizarre to me.
It's raining bricks. That's why.
Raining bricks. I can't explain. It drives me crazy why the Legos are upside down. This is a little program, like a little tank tread program, right? So Logo is, to learn Logo, you have to unlearn everything programming language you've ever learned. If you go in, it doesn't. So, to tank, you declare your program. So I'm using a joystick, right? If button 0, do a routine called left tread. If button 1, do a routine called right tread. If not button 0, turn that tread off. And it loops. So that way, if you let go of the button, it turns the tread off. So it only works with your hands on the gas pedal, so to speak. And that's a design decision I made in my code. You can have it press on and stay on, you press it again, whatever. That's just a design decision I made in the gas pedal. And then Logo, they don't call routines. They call them, what's the code word they use for that?
Words?
No. I forget. They don't call, they're subroutines. Forget the Logo kitty term for it, because they're subroutines. And I said if paddle, so Apple II joysticks are 0 to 255 in either direction. And a paddle is just, 2 joysticks. Joystick is just 2 paddles, X, Y. So I said if paddle 1 is less than 75, turn on port A, set the direction even, etc. And then by doing that, you get lower or on, opposite directions, and you can turn on the tank. I'm not going to do an actual demo of that. I have the basic demo. But, so that's typical Lego code for the Apple II. This is I made a little Lego V8 motor, which is the coolest Lego V8 motor ever made, I gotta say. And this is the thing where I did. There's a clock in the Apple II card, which Logo can access. Oddly, Basic can't access it. It's very strange. unless you use assembly, we don't yet. So I use the, there's in the logo, there's 8 speeds, 0 to 7, 0 off, 7 top speed. So I did it like a 3-speed indicator. So I move the joystick a little bit, it goes on, it like idles, and then the more you push it, the faster it goes. Pretty cool. So that was my V8 motor demo. And I used the optical sensor to see how fast it was turning. I'm sorry, I don't have that demo live now. I tried doing a full 7-speed, but the differences between them were so minute you couldn't really tell what's going on. So this is saying if paddle 1 is less than 170 on the 0 to 255 scale, turn port 5 off, so it's stopped. If it's between 170 and whatever else, turn port 5 set power to 3, set power to 1, set power. Okay, so I'll call it a pass-fail because it worked, but it couldn't do what I wanted it to do, which is a shortcoming of the logo permanent image. Although Lego gave you a stripped-out bare minimum logo, not real logo. Myself and Dan Robotics, one of our members, some of you know, spent a month trying to figure out how to hack it to make basic work, AppleSoft basic work on it. And Dan wanted to do all this assembly, custom stuff, which I didn't want to do because I barely know assembly, and I wanted people to explain it to someone your age. And assembly is very complicated. So we were getting nowhere. And then we found out there was an even more obscure version of the software the next year called Lego Lines, which is a disaster. Lego Lines is like the equivalent of an IDE versus using a text editor. It's a disaster. It was a 300-page manual, and at the very end, like the last page of the manual, it said, by the way, if you want to try AppleSoft Basic with this, here's some initialization code, good luck. Whoa, that's awesome. Their init code works, but their subroutines were Rube Goldberg. Do you know what Rube Goldberg means? You do.
Yeah, it's like a system
It's
like a chain reaction.
right, well, more than that. Rube Goldberg means a system that is overcomplicated for no reason. A simple thing, do a crazy thing into a simple thing. Very good.
This falls on this and then
Exactly, yes. To turn on a light switch or something, yes.
Yeah.
Very good. So, when I show you Lego code, you'll see, in my solution to it, you'll see what I mean. I lose my voice, but I don't know if you read this or not, but you guys read this? Is it clear? Okay, well, this is the initialization code. I'll have to use British English. The initial is Isaac, I don't know why. Where it says line 1001 says S equals 5, that means set your slot number, and then L equals that equation, and then poke those things which are the chips and hit return. So you set your slot number, do the equation, and then what you can do, and that just turns all the chips on. You put that at the beginning of every program, you're good to go. And then to read the data, or send data, it uses this massively complicated piece of algebra. It works, but it's very, very Rube Goldberg, totally unnecessarily complicated. I know why they did it. They did it so that in 1987 they could tell someone your age, okay, set a variable called db whatever, and it tells your variables and it does what you want. But I didn't want to do that. I just wanted to tell it, turn on port 6. I wanted to cut through all the tricks. We found this intrigued me. Oh, I already explained this, sorry. Okay, so, as I mentioned, I last took a programming class in 7th grade in 1986 or something, 87. So my skills left off there. We learned AppleSoft Basic, but we stopped before the next chapter was peek and poke. The school we read it, we never learned peek and poke. So, Dan Robotics, he's an electrical engineer. He knows more in his peaky than I do in my whole mind about this stuff. And he was talking a mile a minute for a half hour. My brain was glossing over. I didn't understand any of it. And he said, blah, 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 yeah, all it really does is peek and poke, blah, blah. I said, time out. Back up. What do you say? He said, well, all it really does is poke the bit you want to turn on. That's it? He goes, yeah. I said, can't we just type that? I guess. To him, it was so obvious as a subconsciously be not even worth mentioning. To me, it was like the skies opened up and the halos and the angels sang. Okay, so, excuse me. He goes, yeah, for 8 bits, and I had this epiphany. And I realized, I was using the word ports, so my English word ports, 0 to 7. He said, Evan, no, 8 bits in a byte. And I was like, oh, duh. So if it weighs the same as a duck, one person got my reference. You get the reference? Okay. All you have to do is type poke L, which is the address of the card, comma, what you want to turn on. Durr. And then I had the further education that I should have had 30 years ago in middle school, that, okay, I said to Dan, okay, I'll just type poke comma 0, poke comma 4, poke comma. No, you have to do the binary. Right, you're nodding, you know this, I didn't. So Dan said to me, Evan, you know at least the binary math, right? He said, yeah, of course. So 1's column, 2's column, 4's column, etc. So what you do is you add up the binary of what you want to poke, go to decimal, poke that. So if I want to turn on port 3, poke L comma 8. Oh, now it makes perfect freaking sense because it's just binary decimal conversion. That 10-minute phone call was like a 5-year or 10-year leap forward in my computer science education. Things I knew on paper, but never implemented before. Things I could read a book and tell you binary, and count the binary, but I never did in person. And I was like, oh, now I get it. Okay, so that was a huge success. This is the code that is running right now in this computer. Is legible? Little?
Yeah.
Okay. So, it would have, basically slow, right? It would have been a lot faster if I did spaghetti code straight through. I purposely did very elegant structured routines so I could explain it to a young person and show exactly what those look like. There actually is a basic compiler for even more speed, but I didn't want to do that. So the actual program, this is my program, initialize interface, this is my instructions, navigation control, forklift control, loop. It never gets to line 70, of course. Line 70 never happens. But I did it for show people there is an end and basic program. 1,000. So that's the initialization code, simple enough. And of course, I couldn't get to initialize it first, and Dan, ever the engineering mentor, reminded me, order of operations in your math, right? You don't do that plus that times that. You do slot number times 16 plus that. Every order of operations. This just prints on the screen, say hello to line@megabot. Line@ is Daniel backward, my friend Dan's name. And so we show this at displays. Okay. I mentioned earlier how to program a Lego joystick, right? 0 to 255 in your direction, pretty simple. It sure stinks if you're a computer user, it's much harder. Oh, hi, Jeff. So much harder. He showed me at a Commodore, it's like 50 lines of code to do what you would let Apple with 1 line of code. It's beautiful. 4 lines of code. So, anyone know Paul Hagstrom for the technical community? They got Apple II guy as well. He's run Apple II Facebook, you know him? Okay. So, when I first started doing this, lack of experience on my part. I said, okay, so M is a variable I pull out of my butt to do the binary to turn on the ports. The binary decimal version. And I got the values, but I figured out what I had to turn on, add them up, flip them in decimal. So I said, okay, if the joystick's one direction, then poke L comma 5, etc. I did it for each one, check it, poke, 4 times. It didn't work. The robot was stuttering around. The robot was walking around all drunk. It didn't work. And this guy, Paul, I was lamenting on the Apple II Facebook group, what's wrong with my code? It should work. And Paul said, no. He said, check your, save them to a variable, check all 4 states, and then poke the variable. Another duh moment for me, right? Suddenly, the robot behaved perfectly. So poke L comma N, just one more time, that'll drive it in. L is the address of the card, N is my variable that stores my decimal equivalent to my binary, turn the motors on. That's simple, that's how it all works. Then, I was outside my apartment, and I heard a dump truck going beep, beep, beep in reverse. I said, I need that. Apple II beep, call 198, turns a beep on. So I played with timing. 1 to 500 is about half a second, and when it backs up, it goes beep, beep. I thought that was fun. What was funny is, since it's constantly moving, when you let go of the joystick in reverse, it keeps going for a split second when you back it up, because it has to compute that first before it returns. I suppose I could have done that if you put it in reverse states, I could do colon and a beep there. I guess I could have done that. Then the forklift code. I put a forklift on the front. This is the most complicated code of all. Touch sensor on top, touch sensor on bottom. So when it goes all the way down, it's going to keep going, and vice versa. And that has to check every state. And that was, actually, Dan Rogati wrote that code for me. But what he gave me was not spaghetti code, but was ruled over. So I took the code he gave me, and I made it, in my opinion, elegant. I added the spaces, you can see what it's doing each time. It has to check every state, otherwise it'll break. This is a close-up picture of the robot here. Originally, in Maker Fair, I had a little three-wheel tricycle kind of car. And Jeff had a Commodore system with Capsella, programming BASIC as well, right? And we were having like robot wars. That was fun. In the middle of Maker Fair, we had our little robot wars and entertain the guests. But I'm like a more power kind of guy, so I kept rebuilding it 19 times and came up with this design. The triangle frame there, so you can lift it by one piece. It's not pretty, but it's awesome. Front view, how the forklift works. Side view. So, modern Lego line-form motors are like RC car motors. They're really strong, 30 miles per hour on those things. These motors from 30 years ago are 4 volts. That's it, they're nothing, no power. So if you have a little tiny motor, how do you make power? Gear ratios, right? They had army trucks in the 1950s with 90 horsepower in 3-ton vehicles. How do they make it work? Gear ratios. So, gear ratios. Right? Little gear to big gear to little gear to big gear about 80,000 times, and you get power. So I had fun with that. And I was in college, I was a double major in English and industrial design, well-rounded nerd. So this was my favorite part of it, was the actual Lego play. Good thing. So that's what I'm best at. Just as a joke, I made little Steve Jobs. So the Lego heads are yellow necks. So I took blue bottoms and a black torso, and took a Sharpie to the neck. So it's little Steve. Little Steve Jobs. Yeah. I think you thought it was bigger. I forgot to bring over for the museum. I made a little Lego Apple II to carry around. Tried to bring it over. Sorry about that. Okay. I'm going to take a step backward. So I mentioned earlier to these people, I have my slides, and I seem to have misplaced them. These are the old version of my slides, so I'm improvising. So experiment 4, as I mentioned, was arousing success. I mentioned experiment number 1 failed, right? And I said it was a critical typo. I'm going to go back to experiment number 1, the IBM basic code. So, IBM basic code says initialize your chips in the first routine. You want to turn a bit on, you do that. You want to turn a bit off, you do this. You want to read the sensors, you do this. You have a delay and error handling. Who in the next 30 seconds or so can find the critical typo in Lego? This is directly copied from the Lego instruction manual of 1987. This is not my typo, it's Lego's typo. Where's the critical typo in this? I'll give you a hint. It has to do with the decimal to binary conversion. Dave? Anyone?
I don't do IBM Basic.
Is it 2 times no string?
Close. Very close. Really hot.
Line 13020?
Nope.
No?
I'll just tell you. So the critical typo,
They put an
Is-
H somewhere it didn't belong.
when they're converting from binary to decimal and vice versa, it goes 0 to 255, right?
Oh.
Whoops. 25.
Oh.
Yeah.
Oops. Oops. No one caught that in 2016 when I was doing my demo. Now, John Chapman across the hall here knows more in his little pinky toe than I do in my body about programming and engineering. No one caught the typo. He said, oh, the timing issue, too new of an IBM PC clone, was running too fast. No, the reason my bits wouldn't turn off was because it wasn't converting to binary right. That's why it didn't work. And the only reason I was able to find that just last month was with the newfound knowledge of 2 years playing with this and I learned from the Apple II side. So I'm going to have some fun at John's expense later over a beer, but I point out that I found a bug that he missed. Because that's not going to happen very often. Anyway, so I haven't yet had a chance to try it with the correct thing, but I'm very confident it'll work. But either way, it's still this root forward stuff, right? Because just like I did the Apple II side, you can brute force it like I did the Apple II side, right? You don't need all this. If new percent is greater than 0, you don't need all this. All you have to do is type, just like on the Apple, it's poke, L, comma, whatever. You out, P in the space, comma, the same information. I can brute force this. I can convert this, what is it, 50, 60 lines of code? This can be done in 10 lines of code, based on what I now know that I didn't know a year and a half ago. However, there's always more to learn, right? So I'll jump back to where I was before. Actually, before I show you the more to learn part, I'll do a little demo. So this is a robot. This is, you might want to stand. You guys want to come up and look at it. You're so beautiful. Just please don't touch anything.
Don't block the camera.
So, that's forward. Back up here. Now, for some reason that I don't understand, the motor in this one keeps getting stuck. I think it's a Lego issue, not an electronics issue. I have to rebuild it, but it would take, time, right, etc. Now, let's lift something on a forklift. So someone give me a smartphone. I use mine. Okay. So hold on, go all the way down first. All the way down first.
Too much.
Yeah.
Hold on. Now you'll see when it hits the sensor, it
Move
stops.
to the right a bit.
And not only will it stop, the light will go on. You'll see the sensor light go on. See? Now it's not quite working perfectly. We get the idea. Okay. So first I tried to lift post-it notes. And my father's girlfriend used to work at IBM marketing, and she had IBM OS2 post-it notes, and it lifted that no problem. Thereby proving an Apple II is more powerful than OS2. I tried to lift an old ID hard drive, and the thing nearly flipped over the way you couldn't handle it. Okay. Something's plugged in backward, I bet. Okay, it's not going up. Maybe it's this one is backward.
My phone doesn't break, but
No, it's not your phone. It's not going to do anything. It's working before. Oh, I had this problem before. That was a problem I was talking about. This is a better one. It's not going up.
What was the button? Was it the top button or the bottom for the sensor?
Well, the top one here tells it can't go down anymore. This one, it comes up and hits this, tells it can't go up anymore. So it should be going up now, no problem. Well, I apologize. There is some bug that is not going up now. But it does work, and there's video proof of it.
And your phone remains safe.
If you look up the YouTube from my Kansas speech from last summer, it does work.
Did the tread still work?
It seems to have probably stopped. It's a problem I mentioned. That's happened before with this. Oh, its program's still running. See? The program's running because it thinks it's in reverse now.
Oh.
But I had a problem with the box.
Yeah, maybe it's a controller issue.
I did have a problem earlier. I'm just going to reboot it because I want to show you. Well, I'm just going to reboot it. 10 minutes before my talk, we went in the workshop and squirted some alcohol in there to try to fix the button.
Oh, it's probably drunk.
Huh? It's drunk, yeah. I've been having this problem actually. And I'm hoping it would not show itself during my demo, but it did. I don't have a monitor right now. I don't need a monitor.
for what sound?
Yeah. Run, robot, back up. Here we go. Guys, here we go. phone back on there. And pretty cool, right?
Yeah.
And now I can drive away your phone. Bye. I got your phone. Thanks for the phone, sucker. Okay. Now, one tread is the one that got stuck on everything. I gotta fix the tread, but you get the idea. So, I'll show you some more things. So, in the manual, there are 65 with assembly documentation. Same thing, initialization code and good luck. At the time, a year ago, I had never used 65 with assembly. I had never used assembly in my life. I vowed to Dan that I would learn it. So I'm proud to say last summer I did my first Hello World in 65 with assembly. Anyone on our list can vouch for it, right? Did a Hello World, got to work, so I'm on my way to learning assembly. You know, for kids. So this is the assembly code. I don't understand it yet, but I'm working on it. Maybe some of you can make sense of that. And I'll post these online later on. More thoughts. There was Logo 2, which I haven't downloaded yet from Asimov. Logo Runner Robotics is unicorn software. No one has the file. If anyone does, it's badly wanted among the 30 of us on the planet who do this kit. Other people have done websites showing how any computer that can talk to a serial board can program this stuff. There's no magic happening. It just shoots bits at. I don't understand why the Logo version uses the clock on the card, the legacy version doesn't. I don't understand why. I want to get a no slot clock for this, so I can make a game or something and have a timer. I've been teaching myself how to correlate. So I accidentally taught myself scaling because the low res screen on the Apple II is 40 by 40, and this, of course, is 256. So I realized if I divide 40 to 256 in my basic code, I can scale it. So I did a little thing where I made a little one-dot low-res thing in the Apple II, a little block, and as I drive the robot around, the block chases it on the screen. And I did it for high-res, and it worked. Pretty cool. A little fun thing that would be fun to try. I don't own any Mindstorms, nor does VCF itself. If anyone wants to donate Mindstorms to VCF, we'd love to have it, so that we can see if we can make the Apple True control Mindstorms. That'd be fun. There were 64, it's no longer supposed to be, I've confirmed. There are C64 and BBC micro versions. 64 wouldn't need the card because it has Redshift built into the computer. There was this plotter kit you can buy, where you can write software for that too, which Dan has, but we don't have the software. Dan also pointed out to me that if you put multiple cards in your computer, you can control multiple interface boxes. Well, I'm limited to 8 ports. What if you attach 4 of those things? You could have the coolest robot ever, right? Next last slide. So if you want to get this kit, these kits, especially the critical interface box, the schematics for the cards and the software is all online. There's no schematics online for the box, but we're going to do it soon. You can buy the boxes online anywhere from like $50 to a couple $100. But I found one, untested, no power supply, as is, unknown condition for 25 bucks. Figured if it doesn't work, my friends like you guys can fix it. Got it in the mail, opened it up, tightened some things down, it worked. Got mine for 25 bucks. But we'll post the schematics so anyone can build one. This guy, Alex Lucasi, this Australian guy, has what is currently the best website about this. It's loaded with technical detail, but it doesn't have much in how to actually use the kit. So I'm making my website about that. We're going to maybe do a child-parent legal learning station here at the museum, because whether you're an old fart like us or a young man, computational thinking and logic is computational thinking and logic, right? One of our members is a computer science teacher in high school, Adam, and he pointed out to us that modern parents would, modern CS teachers hate this. Oh, it's a line number interpreted language. There's nothing good can come from that. But logic is logic. The last slide. Jeff and I were asked to write an article for IEEE Spectrum about his Capsella and my Lego thing. We did. It's an awesome article. But it's a little bit deprecated because that's before I learned all the bugs. So it'll be much better if I can do it now. I'm learning assembly, and that is the end. Any questions? Someone has a question, maybe go ahead.
I have something to say.
Yes, Jim, what's your name?
Logan.
Logan, I'm in. Have you had before?
I recently saw this video about this guy from Andorra. He built his arm was like misfigured at birth, and he ended up building his own prosthetic arm out of Legos using Technic and limestone pieces.
Okay, cool. Before it was called Technic, in our day, it was called Expert Builder.
I've got one.
Yeah, so
Can you humor me on your robot here? Can you move the forklift arm all the way down? I'm curious. I have a thought.
well, the reason it stopped is the interface box was broken. It wasn't
I don't think it's a robot. Okay, now try
that
to
sensor that you called it.
Now try going back up.
It's a faulty sensor.
No, I think you got the sensor swapped.
Yeah,
Try it one more time back up. Yeah,
no,
nothing?
faulty sensor.
Yeah, I'm curious. If you pulled that cable, would it still do it?
If I disconnect the sensor cable,
Yeah.
top sensor is cable number 6, I believe. I see your voice now.
You might have it swapped.
7.
Pull them both.
I tried it. Great.
Yeah, so it's a bad sensor.
Or it's swapped.
It's either a bad sensor getting stuck, because I remember using those sensors before with Mindstorm
Yeah,
and stuff.
I have some extra sensors, and you can buy them readily on bricklink.com.
Yeah, it's a common part.
I did try storing some alcohol in there. It worked better for a little while. So maybe the problem wasn't my stop button, it was a bad sensor.
They get tarnish on them.
Real-time troubleshooting, gotta love it. And this one piece gets stuck as well, but that's a Lego issue, not a.
Yep.
So, see, it's not going as smooth as that one is. Anyway, that's all sure.
Thanks, Evan.
Thank you.
Thank you.
What's the name of the kit?
Well, that's actually up for debate. DACTA, D-A-C-T-A, was Lego's educational series. There's 2 ways you can buy it. You could buy just the box itself, called the 9750, 9750. The 9700 was a whole kit, only sold to schools. So as I mentioned earlier, I'm making a website, which is currently live, but the content is going to be there, actually there yet. I'm going to put all the schematics. I'm not going to put manuals up because I don't want to get copyright infringement, but that other guy did, I don't think it is. I'm going to put up everything you need to build your own version, basically. Yeah, the 9700 Technic Control Center. And they kept reusing that name. If you go to my under construction website, which is not wink wink, LegoRobotMuseum.com, it shows all the different kits, and you use the same model name for different kits over and over.
Okay. So you
That's
said
for sure.
it was the 9700 was the entire kit, and what was just the box?
The box is part number 9750. Yeah, but I'll post the schematics, so hopefully you guys can all make boxes.
99 or best off.
How did you figure out the 225 versus 255?
I'm trying to remember. It was just like last week. Actually, it was Dan. So I was going over, I called Dan last week to ask him, I said, hey, that brute force thing we did, the trick we did on the Apple, I said, that should work on the M side too, right? And he's like, yeah, in theory, it should work. And we hadn't played with the idea of code in a couple years, so I sent it back to him. He's like, wait a minute, there's a typo. I was like, oh, that's why it didn't work 2 years ago. That typo is a big error. There was no syntax error, so work should, you never would have known it. That typo cost me a lot of sleep in summer 2016.
So what does that box actually do? Does it convert?
What box?
That one.
What that box? Well, that
Does it convert the
It
the
takes-
binary out from
yes,
computer
it takes.
back to like analog? It just voltages on and off.
See, that's the extent of my engineering knowledge.
I think it's pretty much a box of relays.
You guys answer better than me. Yeah. I'll go back to the picture of the inside.
To the motors, right?
Well, yeah, go back. That's right. There's no data. There's no data inside.
No card, no.
There's no actual information. Back to the picture of the box.
So it's basically taking like the binary signal from the program
Yes.
and just converting it.
There's nothing. You get a better picture of the box. See it a lot better, sir. See it a lot better here. As I said, it takes the binary data. It just turns all it takes binary data. It says which one should I send 4 volts to.
Like the
Right.
That's it. Everyone assumes there's intelligence in there. There's not. It's dumb as hell.
Something like that, it seems like you wouldn't even need.
I couldn't comment on that. But all I know is it takes binary data out and says you want to turn on bits 4 bits 4 and bit 7, and you send voltage to those two ports. That's all I know. There's no data being sent. All the software is in your Apple II or your IAPC. In my case, a compact port configurator relation 1.8.9.